we are back into our discussions. Remember, by the previous video, we are introduced into the new topic, that's the algebraic fractions. Right, so today we look at something else, not quite different from what we've been doing. Remember, we are discussing about the simplification of algebraic fractions. That's addition, multiplication, subtraction, and division. So this time around, we are going to complete the first part. That is the addition and the subtraction of the algebraic fractions. Right, with me here, I've got some examples that will guide us on how best we can simplify the algebraic fractions by addition and the subtraction. Just like now, how do we add, how do we subtract the algebraic fractions? I've got 3 examples on the board, but the last one, that is example C, will be left for you as an exercise. So please, as usual, let us be together and follow the tactics on how we simplify the algebraic fractions as such. Right, by example A, here we are. Solution. We are asked to simplify, let's say a plus b over a squared plus ab minus a plus 2b over a squared minus b squared. So I'll take that one down this way. That's a plus b over, that's a squared plus b, that's ab minus, that is a plus 2b over a squared minus b squared. So can you try to remember by the previous videos? You can follow the link down here. From what I said, each time you need to simplify the algebraic fractions. The foremost thing that you need to do and consider in this case is the issue about factorization. Try to check the expressions that are there on each and every fraction. Can they be factorized? So if it is possible to factorize those expressions, please do that. The aim is at least to simplify the fractions as such, because it's easier to operate the fractions which are well simplified. So like in this case, I'll check first of all with this fraction here. The numerator is a plus b. There's nothing we can do with a plus b. We can factorize that one. So we just have to take that one down like say a plus b, like this. Over, if I look at the denominator as an expression here, a squared plus ab, you find that here there's a common factor that can divide in a squared and ab. So I'll have it divided like this. A into a squared give us a into ab give us b, right? Then I'll go to the other fraction where we are subtracting a plus 2b. So here I'll still have my a plus 2b like that, because there's nothing you can do with that. But if I look at the a squared minus b squared, you'll be able to realize by JC weight that, see, this is just a difference of 2 squares. So you can factorize this one out by just coming up with the conjugates of the expressions. So a squared minus b squared, the factors of which it will be a minus b and then a plus what? Plus b. Right. So now, if we can look at this part here, the first fraction, you realize that as much as we have factorized the denominator to have a, open brackets, a plus b, you'll be able to see that the top part, the numerator has got a plus b, denominator a plus b. So here you are free to simplify this one by dividing a plus b into a plus b, which gives you a 1. So here, it means here up here, we have got a 1 over, that is a, that's the, what now we're going to get from here. So it'd be a 1 over a. You can see this now has been simplified. It was a fraction with the big expression, but now the expression has been trimmed into 1 over a. So this is the one now which is supposed to subtract a plus 2b over a minus b, then product a plus b. Right. So now from this stage here, you are there just to follow the procedures of fractions, where we operate the fractions by addition or what subtraction aside. So every fraction which is there to be simplified first of all, we have to first of all consider the common denominator. So we are there to find the common denominator for this one, which is A, and A minus B product A plus B. So the common denominator for this one and this one, you realize that say it is A minus B, and then A plus B as such. Then what do you do with that common denominator? You let these two denominators divide into them, and the result has to be multiplied by the numerators. So here we begin by having A into A minus B, A plus B. You find that A only cancels with this, and the answer of which it is this expression here. So you take A minus B, A plus B multiplied by 1. So you have like 1 multiplied by A minus B, and then A plus B, like that. Right. After, you write your minus like this, and then you need to divide A minus B, A plus B into A minus B, A plus B. So you'll be able to see that this one will cancel with this one here, and that is A. So it is this A which has to multiply by what? The numerator, which is A plus 2B. So I'll have my A here. It is positive, but now since in the middle you have with the negative, so this A turns up to be negative A. So it will be now negative A to multiply by A plus what? 2B, like this. Right. So if you can look at this, we'll be able to realize that now the next thing here is just like historical, whereby the operations now are simple. You need just have to simplify where necessary. You begin by removing the brackets, and then you go like that. So let's see what we have from this. So I think you are able to see this one. I will have the top part because of space, right? But in your case, you can go back. If you still see the previous space, you can play the video. There's no problem there. So let me take this one off. Right. So what we have now is just like we need to simplify this. So you'll be able to see that this is these are the conjugates of each other. So how do we simplify this multiplied by that? We will not know for sure that if I've got conjugates of such kinds and we multiply, the result we get from that is just a difference of 2 squares. So I'll simplify this by that one. What I'll have is like 1 in bracket, then A, that's a squared minus B squared. That's what we have on the first part. So here it's just like A multiplied by this one, you get the same thing. So this is just as good as just writing what? A squared, that's a minus B squared. That's what we're going to get from the first part of the bracket. Next, we need to simplify this one by whatever terms we have inside here. So we consider A, negative A, to multiply by A and then multiply by 2B. So what we get from here is just like negative A times A give us negative A squared, and negative A times the positive 2B, it will give us, that's a negative, that's A 2AB. Then this now will be over the denominator down there, which is A minus B, and then A plus B. That's the way it goes. Right. So from there, keep on checking on the top part. Say, what else do we see we can do? You'll find that the moment we have just created the brackets, you realize that we have got some terms which are alike. So you can arrange like terms wherever possible. You do that and simplify them out. So here we have got A squared and A squared as like terms. So let's simplify them out. So you see that A squared, subtracting A squared, we get a 0. But you have got negative AB, so we have got negative B squared and negative 2AB. These are unlike terms. So what we have there on the top, we have negative B squared minus 2AB over A minus B, and then A plus what? A plus B. Right. Still more, considering the top part, you'd find that we have a common factor here for negative B squared and also negative 2AB. So it is possible in that case you can still more have that chance to factorize that. Or in this case, since there's no factor that can simplify with the denominator, what you do there, you can even leave like that. But it's better somehow to simplify the expressions to the simplest form. So what do? We are going to factorize this part here. That's the numerator, where we can see there we have got a common factor dividing into this and that as negative b. So I have my negative b like this, open bracket, negative b into b squared is a b, and negative b into positive 2ab, you get what? That's a positive what? 2a. Right. So this, what you have at the end here, it is the solution to our problem there, over a minus b, and a plus b as such. Now, once we have factorized in this way, we have that chance to check, to say, do I have a common factor that can simplify with the numerator and denominator? Meaning to say, do you have an expression that can cancel the top numerator and the denominator? You find that if we can check the terms in the expression, here we have b plus 2a, here I've got a minus b, here we have got a plus b. It means in this case, we don't have a common factor. Don't make those mistakes of just cancelling like b and b, a and a. That type of mathematics does not exist. Of course, I realize this is the most common errors among your learners. So try, please, not to think of that one, but consider the expression at large to be simplified the other one in same manner. Right, so this is our answer to our question number A. Right, now let us also go to question B as fast as we can, because now we know the procedure and the tactics on how we can deal with the algebraic fractions. Right, so you can play the video so that you can still more keep on following the procedures for question number A. Right. Question B requires us also to simplify. That's a 4 over x minus 3 plus c talk of 2 over, that is x plus 2, and then minus c x plus 7 over x squared minus x minus 6. Right. You are to simplify that one. There are 3 fractions to be simplified. Now it's a combination of 2 operations, one addition and then subtraction. Right. So rules remain the same. First thing, consider each about factorization. Where you can factorize, do it, but where you cannot, leave it. So cross check first of all the fraction there. Looking at fraction number, first fraction, here we have the first numerator. Here I've got x plus x minus 3 as a denominator. Nothing we can do with that. So it means I'll just take this one down here like this, x minus 4 over x minus 3. The same applies to the second fraction here. There's nothing I can do with it 2, and also x plus 2. But now if I can look at the last fraction here, the top, we can't factorize it, we just leave it like that. But if you look at the denominator of which, you'll be able to learn that this one can be factorized. So if you factorize that one by the difference of 2 squares, not difference of 2 squares, solve for that by grouping method, you'll be able to obtain the factors such like x, that's a minus 3, and then x plus 2. That's what you get from there. Right, so x minus 3, then x plus 2 are the factors of this expression here. So you are asked to do that. Then what do you do next? Find the common denominator. Right. So common denominator for x minus 3, x plus 2, x minus 3, x plus 2 is an expression that carries all the expressions at large. We have to see that that denominator has got the x minus 3 within it. Should also indicate an expression x plus 2, right? So that when we divide, we should be able to see these expressions of denominator are able to be cancelled with at least one of them. So the required common denominator in this case is x minus 3 and x plus 2. So you find that this one is common, this one will be able to get into this will get into that one will get into this one. What next? Let's divide. So you have got x minus 3 getting into this denominator. The answer it will be x plus 2. It's because x minus 3 will cancel with x minus 3. So you have x minus 2 as the answer. This to be multiplied by 4. You have something like this, 4x plus 2. Then you go further to the other part of the fraction. Here you write plus, and you let x plus 2 get into x plus 2. and your answer is x minus 3. So this x minus 3 should multiply by 2 here to have something like 2, open bracket, that's x minus 3. And then finally, we have our x minus 3, x plus 2 to get into this one here. So when x minus 3, x plus 2 divides into x minus 3, x plus 2, we have 1. This one gets here once. So it is the one that is going to multiply by what? Numerator, which is x plus 7. But now here we have got a negative, so here we're going to write the same minus. But since it's getting here is positive 1, and that one has to be multiplied by that, that one now turns into be what? A negative. So it will be 1, open bracket here, x plus 7. Right. Sometimes we don't necessarily write a 1, but in this case it's important because this one has got a negative. So there are special issues that we will do in order to deal with the negative as such. Fine. Now what else do we do? Let us clear the brackets. So we're going to expand the first expression, second one, and the last one. The first expression we have got 4 multiplied by x. We have got a 4x. 4 times 2, we have got 8. And then 2 times x, we have got 2x. 2 times negative 3, we have got negative 6. And here we've got the negative 1 to be multiplied by terms inside. You have got the negative x, the negative 7. And this one is over x minus 3 and x plus 2, like that. Now, what do we do next? It's historical again. That's things are just applied as it was. So here, let's just simplify the like terms and see what we have at the very end. Right. So if you can cross-check the numerator here, which has got this expression here, you're going to realize that say 4x, 2x, and negative x are like terms. So what are we going to do with them? Let's simplify as such. So it means here we have got 4x plus 2x. That one gives us 6x. The 6x should subtract negative x. So it's more like subtraction is the same like subtracting the x there. 6x coming from 4x plus 2x gives us 6x. So 6x minus x, that gives us 5x. So it means the result on the numerator there, we have got 5x for the first group of the like terms. We also have got 8, negative 6, and negative 7 as like terms. So let us also simplify them as such. So it means we have got 8 here, minus 6, that gives us a 2. And that 2 should subtract a 7. And the answer we have there is negative 5. Right. So we have 8 here, minus 6, we get a 2. I repeat, and that 2 should subtract a 7. The result is negative 5. So on top here, it means we have got 5x minus 5. That one should be over x minus 3, product x plus 2. Right. If we keep on checking on the top part, you find that something else can be done. What is it? You'll be able to see that the terms in the expression, they have got a common factor. In that case, it's a 5. So what you do there is like that 5 can be allowed to divide in both terms. That is 5x and negative 5. So what we have is just like if we let 5 getting into 5x, then that is x. And the same 5 getting to negative 5, the answer is negative 1. Right. So which means at the very end, our final solution to example B will be 5, open bracket, x minus 1, close bracket, over x minus 3, and the x plus 2. Right. So this is the answer. Right. So by what we have just done here, I have all hope that you have now mastered the procedures on how you can operate the fractions by addition and subtraction. Remember always to consider first of all issue about factorization wherever it is possible. That one helps a lot because there, if you factorize It means you're going to have a simplified common denominator of the fractions and be able to simplify the large termed fractions to the simplest form. In such a way, it means your operations will be much easier. Right, so what I need you to do before we close this chapter, you suppose to at least try the example C. So I leave you this one as your exercise. So do exactly as we have just done here. Remember to factorize first where possible, but where you can't, just proceed with the operations. So here we have x plus 3 over x squared minus 1, then minus 3 over 2, open bracket, x minus 1. Right, thank you very much for being together, and I hope that we will also be together in the next discussion where we are going to look at the multiplication and the division of the algebraic fractions. Right, so still more, my advice remains the same. Let us follow the lessons so that at the very end we have to be really channeled in the right way in as to how we can simplify the algebraic fractions. So start right away from the beginning. You watch all the videos that we have just have had by the link down here. Right, at the moment, let us stop here. We'll meet again in the next video where we'll look at the multiplication and division of the fraction. Thank you very much.